So this question here, we're trying to work out this angle here, and we're told that it should be 60. So we're going to use cosine rule. We've got three sides here. Cosine rule works with the three sides of a triangle, just like Pythagoras does. So I'm going to call this side A, this one B, and this one C. I know there's letters B, C, and A on here, but I'm just going to do it in to fit the formula for cosine rule. And this one I'm going to call angle A, not angle B. So it is going to be A squared equals B squared plus C squared. Take away 2BC cos A. As long as this is A and this is the opposite side, it doesn't matter what these two sides are, B and C, as long as they're enclosing this angle here. So if you put these things in, root 14 squared is 3 root 2 squared plus root 2 squared. Take away 2 B C cos A. Okay, root 14 squared is 14. This here, root 2 squared would be 2, 3 squared is 9, so it's 2 times 9 is 18. Root 2 squared is 2. Now this is going to be 2 times 3, which is 6, and then root 2 times root 2, which is 2, so that's going to be 12. 6 times 2 is 12 cos A. So we get 14 is 18 plus 2 is 20. Now we don't do this subtraction here because this 12 is multiplied by cos A. We can do this because this addition is separate. So this is negative 6, if I take away 20 from both sides, is negative 12 cos A. So cos A is negative 6 divided by negative 12, which is a half. So therefore A is cos to the minus 1 of a half, which is 60. We know that because of the definition of some of the exact values that we know for an equilateral triangle, 60, 60, 60. If we split this down the middle, this triangle, this is the triangle we start with, so that's 2, 2, 2. We're going to take this right angle triangle out. So this will be 2, this will be 1. If this is 60, cos is adjacent over hypotenuse. So the cos of 60 is this 1 over this 2, so it's adjacent over hypotenuse. There we go. Hence work out the area of triangle ABC. So we've got a base and we now need a height. So that would be the height of the triangle, so we're going to try and work that out. So if I imagine this little triangle here, with C on the top and B there, and a little right angle there, so I'm just copying this out. This is root 2 and this is 60. So to work out the height, we're going to use, which I'll call H, we'll use sine. So if I look at this triangle here that I used before for my exact values, we need to know this length here. Now using Pythagoras, I know that 2 squared equals 1 squared plus this h squared. So that's 4 equals 1 plus h, so h is 4 take away 1 is h squared is 3. That means h is the square root of 3. So I know that that is root 3 on that triangle. So if I want the sine of 60, it is the opposite over the hypotenuse, root 3 over 2. So I'm going to use that in here now. To work out the opposite of this triangle, I know that it is going to be the sine of 60 times by the hypotenuse. Sorry, to work out the, okay, so I'll call that O to avoid confusion. To work out this opposite here, I'm going to do sine of 60 times by this hypotenuse. So sine 60 times by root 2. So sine 60 is root 3 over 2 times root 2. Now, if I want to work out the area of that triangle above then, so I'm going to do this base times that height. I've just worked out that that is root 3 over 2 times root 2. So multiply that by that and then divide by 2. So area equals 3 root 2 times root 3 over 2 times root 2, and then we want to divide that all by 2. So root 2 times root 2 is 2, so that 2 divided by that 2 is going to be 1. So this and this are going to disappear, so it is going to be 3 root 3 over 2 is all we're left with.